Okay, I was asked to, it's weird, there's something reflecting there, not sure what that is, to solve a problem from chapter 6, homework, maybe homework 7, on steady state or t tending to infinity or final values. On exams in circuits 1, if you see any circuits with more than 3 or 4 storage elements, so this one has 1, 2, 3, 4, 5, 6, 7, this means we are asking you to draw the circuit with the inductors shorted. So this, we're going to short them, and the capacitors open, and from then on it's a question of voltage drops and currents through those wires that the inductors become, or voltage drops that the capacitors become. We need to worry about the pluses and minuses. This one I wrote a plus there, but it's really the plus on the C4. So let's try. This looks like a fancy circuit, so if you're watching this video, you can stop now and try, and then compare with my circuit. Hopefully I got it right. So luckily there's no U of T's here. If there were, and 5 milliamps U of T would be, this is for T tending to infinity. So you'd make the switch actuate and the U of T happen, or U of minus T turns this into a 0. The 1 of 1K here will be in parallel with an inductor. So this here will be my I1. And then there's 10 volts the wrong way I drew. There are 10 volts here that goes to a 19 volt, and then to the second inductor, and then to a 3K, and this goes down to a 2K and a 3 volts. And then the 4 and the 5K I'm going to put together as a 9K. The reason I can't make the 3K and the 2K in series is that I need this node here, because this is my minus and plus or of C1, and because from here to here it's my minus and plus of C2. So this is how the multimeter, so you can think of C2 as, of capacitors, as multimeters, where you're putting the negative terminal here on this node and the positive terminal here. But in between 4 and 5 there's nothing. In between L2 and down here there is a 6 volt drop. And this is the plus, so what happens is, because L2 is a short, this here is the plus of the C4 and the plus of the C3. So this here is the plus and plus of C3. And then this is the plus and minus of C4. And this is the third inductor. I'm going to make it a short, and then there's a 10K here. So this is the circuit. There are only 2 loops, so there will be current through here. So the current through L2 is not going to be 0. And there's current here, except this is shorted with the 1K, so I can very easily tell some of these currents and voltages. Often on an exam, once you have the circuit, you're not going to need a nodal or a mesh. So, and I suggest you look at which ones are the easy ones. And look, this 10K here, even though it's being measured, C4 is measuring from here to here, this current, do I have a pen? This current here is 0, and therefore IL3 is 0 milliamps or 0 amps. I1, I can see here that's minus 5 milliamps. And I2 I'm going to have to actually solve for, so I'm going to wait a little bit. For now, let me see what else I can look at. This 3K will have the same IL2, this 2K also, this 9K. But C3, for example, is measuring from here to here. And so this plus is on this side, and the minus is on this side. So VC3 will be 10 volts. Now VC4, I can't tell because it's going to be this voltage here, plus or minus 6, and then VC2 is this. VC1 I can't tell either. So I actually have to do KVL and Ohm's law for all of these. Yeah. So first let me find this IL2, because what happens is as soon as I have IL2, I'm going to have all these voltage drops here. So let me do KVL. Sorry, that KVL on this loop here, on the main loop, on the L2 loop. So it's going to be minus 3 plus VC2. Oh no, it's not plus VC2, plus V2, which is this guy here, V2, plus V3, which is this here, minus 19, plus 6, plus V9 equals 0. Now all of these, V2, V3, and V9 are IL2 times the resistance. So I know that, you know, V2 is 2K, V3 is 3K, and V9 is 9K times the resistance, times the current. So I'm going to do minus 3 minus 19 is minus 22 plus 6. I hope that's minus 16. And then plus that current IL2 times 2K plus 3K plus 9K equals 0. So this will be 14K. So IL2 will be 16 divided by 14K, which is like 1.2 divided by 14 is almost 1, or yeah, it's close to 1.1 milliamps. So now I have IL2, I can already enter this here. And now I can find all the other voltages across the capacitors. So let's start with, let's see, VC1. I've done this several ways, but I'm going to show you, I think, the way that's possibly the hardest for me, which is to do a KVL on the loop, including the voltage across the capacitor. So I'm going to do KVL here as if the capacitor was part of this loop here. And I'm going to dot it so that you know my pathway here. So this would have been minus VC1. And that's what I'm trying to find is the voltage across the capacitor. And now here there's no voltage drop because this is a short. And then I find the 10 there, minus 10, plus 19, minus V3. So equals 0. So VC1 will be 9 minus V3 is 3K times that current, 1.1 milli, which is 9 minus 3.3, which is 5.7 volts. So that's VC1. Now let's try VC2. VC2 is this here. And I'm gonna change colors and go around with a highlighter first, with an orange highlighter. So now, if I had that capacitor here, it would be here, this plus, and then I'm gonna go around here, and then around the same, like -10 here, and then here, and then I have to get back to that. So this is my orange VC2. Let me see if I can write this, use this VC2. This is a short -10 plus 6 plus V9 equals 0. I do have an orange. Let's take a look here. VC2 will be 4 minus V9, which is 9K times 1.1 milli, which is 4 minus 9.9, which is minus 5.9 volts. So VC2 is minus 5.9 volts. Now the last one, I'm going to use the same method, except that I already know that this here is 9.9 volts. So VC4 will be 6 minus 6 plus 9.9 volts. So I'm gonna do my method, which is, I can see here where the plus is. Oh, I'm using the brown again, sorry. I meant to use some other color. VC4, I'm gonna say that this plus is aligned with that guy, so there's 6 volts there, part of VC4, but there's also the 9.9 volts. So it's really 6 plus 9.9, which is 15.9 volts. So I hope this helps show you how to go around in voltages and currents. Often it is just getting the circuit drawn in a way that you can understand the loops, and then getting these voltage drops between places. So the second circuit here has no capacitors and inductors. That's the kind of circuit we trained in the very first homework assignment with voltage drops, and first and second homework assignments with voltage drops and currents in very tricky circuits. No need to know differential equations.